Polynomial long division. So dividing polynomials is easiest if you're able to factor the numerator and the denominator. And the reason why is if you factor the numerator, factor the denominator, if they have a common factor on the top and the bottom, we know that anything divided by itself is equal to a 1. And so we can essentially cancel out the factors that are the same because they simplify to a 1, and when you multiply 1 by whatever's left, you end up with just whatever's left over. So if the polynomials can factor, it makes division easier. So let's look at number 1. So let's try factoring out number 1. And so we're going to factor the numerator, the 6x squared minus 5x minus 4. It has 3 terms. There is no GCF, so we're going to go ahead and go forward with the AC method. So we need 2 numbers that multiply to negative 24x squared, but add up to be negative 5x. And those 2 numbers are negative 8 and 3. And so we break apart the middle term, 6x squared minus 8x plus 3x minus 4. The first 2 have a 2x in common, so we pull that out, and we end up with 3x minus 4. The last 2, the only thing those have in common is a 1. And so we take the 1 out, and we still end up with 3x minus 4. And so our factored form for the numerator is 3x minus 4 times 2x plus 1. Now let's factor the denominator. So the denominator is 18x squared minus 24x. So there's only 2 terms. So let's look for a GCF. I know that I can divide out a 6x from both of these. So we have 6x times. We are left over with 3x minus 4. And that's as far as we can go because, yes, we have 2 terms here, but this is not difference of squares, it's not difference of cubes. This is about as far as we can go. Now that we have everything factored, let's put it back into the fraction. So we have the numerator is 3x minus 4 times 2x plus 1 over the denominator factored is 6x times 3x minus 4. And what we see is that we have 3x minus 4 in the numerator and in the denominator. So anything over itself divides out into a 1. So what we have is 1 times, and then whatever's left on the numerator is 2x plus 1. Whatever's left in the denominator is a 6x. And we know that 1 times anything is just itself. So your final answer for the division of these 2 polynomials is 2x plus 1 over 6x. Now, we know we've seen that not everything factors out. And so what happens if you cannot factor the numerator or the denominator or both? Well, that's where long division of polynomials comes in play. Now let's review how to regularly do long division. So if we look at number 1, this is just regular numbers. So we would take the 480 on the inside divided by the 5 on the outside. And then we would ask ourselves, what times 5 makes 4? And we say nothing. So then we move on to 48. Well, what times 5 gets us close to 48? Well, the closest we can get to 48 is multiplying by 9. So we take 9 times 5 and we get 45, and then we subtract. So 48 minus 45 is 3, drop down our 0, and then we start over. So now we say, what times 5 gets us close to 30? Well, I know that 6 times 5 is exactly 30, and then I subtract and we get 0. And remember, this is the remainder. And so what happens is 480 divided by 5 is equal to 96 without a remainder. So now we look at number 2, 428 divided by 5. So again, we set it up, 428 divided by 5, and start the process again. What times 5 makes 4? Well, we can't do that. So what times 5 makes 42, or at least something close? And I know that 8 times 5 makes 40. So then we subtract. 42 minus 40 makes 2, drop down the 8. And then we start again. What times 5 makes 28? Well, again, the closest I can get is 5, because 5 times 5 will make 25. Then we subtract, and we get a remainder of 3. It is a remainder because there's nothing else to bring down. So our remainder here, our remainder is 3. And so the way you used to write this back in elementary is you would say 85 remainder 3, and that would be your answer. Well, polynomial long division follows the same general process. The numerator is the inside of your division sign, and the denominator is your divisor. What are you dividing by? And so the general steps to polynomial long division is the same idea. So instead of reading the steps, let's look at example number 2. Let's look here. Long division of polynomials. So the setup is going to be generally the same. The first one is the inside. So we're going to have x squared minus x minus 30 divided by, and then the second one is the outside, x minus 6. Now, again, the process is generally the same. We say what times x gives us an x squared. Yes, there's a 6 here. We will come back to that 6. So what times x gives us x squared? Well, we know that x times itself gives us x squared. Now we're going to actually do the multiplication, just like we did before. Once we put the number up top here, the 9, we multiply 9 and 5 together to get 45. So now we're going to multiply x times x. The problem is x is not the only thing outside. I have the entire thing x minus 6. So it's kind of like distribution. X times x will give us x squared. Then we need x times negative 6, which gets us negative 6x. Now that we have done the multiplication, after that, let's look back at our number example. We multiplied, and then we subtracted the inside from what was the multiplication. So same thing here. Now that we have multiplied, we're going to subtract everything. And again, you're subtracting more than just one thing. So it's kind of like distributing out the negative. So this positive x squared turns into a negative. This negative 6x actually turns into a positive. Well, x squared minus x squared is 0. Negative x plus 6x, because remember, a negative times a negative makes a positive. So negative x plus 6x makes 5x. And then just like in the regular numbers, you drop down the next thing. In this case, it's a minus 30. And then the process repeats itself. So now we start over. We ask ourselves, what times x makes 5x? So in this case, we just need a positive 5. Because, just double check your math, 5 times x makes 5x. So now we can multiply. 5 times x makes 5x, and then 5 times a negative 6 makes a negative 30. After we subtract, or after we multiply, we subtract. So this positive 5x turns into a negative. This negative 30 turns into a positive because of this little subtraction sign on the outside. Everything is backwards. And now we can actually combine these together. 5x minus 5x is 0. Negative 30 plus 30 is also 0. So the remainder here is 0. And remember, you know you're done and you have a remainder when there's no other terms to drop down. 30 was the last thing I had. So I have a remainder of 0. So that means the quotient of these two polynomials is simply x plus 5. Remember, your answer is up here at the top. Now, let's look at example 3. We have 6x to the third plus 5x squared plus 15 divided by 2x plus 3. Now, if you notice, we're actually missing a number here. We have x to the third, we have x squared, and then we jump down to something without an x altogether. So we're missing our x's. So what happens is we need to actually put a 0 for whatever term you're missing. So since we're missing an x, I need to add 0x in its place. Otherwise, your like terms are going to be off in your division. So make sure you add a 0x for whatever like or whatever term you are missing. So our inside polynomial is actually 6x to the third plus 5x squared plus 0x plus 15, all divided by 2x plus 3. I'll do the first step of the division, and then you guys are going to continue with it on your own. So to start off, remember, we need to ask ourselves, what times 2x gives us a 6x to the third? Well, the answer to that is a 3x squared. I know that 3 times 2 makes 6, and x squared times an x makes an x to the third. Now that we have the number up top, we need to actually multiply. So 3x squared times 2x is 6x to the third. 3x squared times 3 is a positive 9x squared. Now that you have the numbers that you need, we're going to subtract. So remember, it changes all the signs. So this 6x to the third is a negative, and this positive 9x is actually a negative. So the 6x to the thirds makes 0. 5x squared minus 9x squared makes a negative 4x squared. Then drop down the next available term. And that's why we needed this 0x here. That way we're still in line with 3, 2, 1, and no x's at all. Okay, pause the video, see if you can finish off this and get down to the remainder on your own. Here's what you should have had for your remainder. You should have had a remainder of 6 and 3x squared minus 2x plus 3 as the quotient. So the way we write our answer when there's a remainder is we're going to write the polynomial that divided evenly. So this part that divided evenly was 3x squared minus 2x plus 3. Then we need to add on the remainder. So the remainder is going to be 6, but remember, we still have to technically divide the remainder by 2x plus 3. It's just not a whole piece. So it's the entire polynomial that divided evenly plus the remainder over what you divided by, because this is still part of it, it's just a fractional portion. And so this is the answer when you have something that's a remainder other than 0. Let's look at example 4. So we have 2x to the fourth plus 3x third plus 5x minus 1 divided by x squared plus 3x plus 2. So now we're dividing by something other than a linear divisor. So like x squared, x to the third, we have higher exponents on the outside. The setup remains the same. We have 2x to the fourth plus 3x to the third. Now remember, we're missing our x squared, so we have to add plus 0x squared plus 5x minus 1. Then the outside is the x squared. So it's going to be x squared plus 3x plus 2. Now, if you are missing terms on this outside piece, you still need to add them in. So for example, if we were missing 3x, we would have had x squared plus 0x plus 2. So in either polynomial, the first one or the last one, if you are missing a term, please make sure you remember to add a 0 in its place as a placeholder. Well, the process doesn't change. We still start by asking what times x squared makes 2x to the fourth. Well, I know that a 2x squared will multiply correctly. 2 times 1 makes 2. X squared times x squared makes x to the fourth. And now we multiply. But now I'm multiplying 3 things instead of 2. So 2x squared times x squared is 2x to the fourth. 2x squared times 3x is 6x to the third. 2x squared times 2 is a positive 4x squared. Now that we have multiplied, we're going to subtract. So again, distributing this subtraction sign will change all of these signs to be the opposite of what they already are. So 2x to the fourth minus 2x to the fourth is 0. 3x to the third minus 6x to the third is negative 3x to the third. 0x squared minus 4x squared is negative 4x squared. Then we drop down the next term, plus 5x. And now we start the process again. So we ask ourselves, what times x squared makes negative 3x to the third? Well, I know that negative 3x will do the job. Negative 3 times 1 makes negative 3, and x times x squared makes x to the third. And so we multiply. Negative 3x times x squared makes negative 3x to the third. Negative 3x times 3x makes negative 9x squared. Negative 3x times 2 makes negative 6x. Once you've multiplied, make sure you subtract everything to find out what's remaining. So a negative and a negative makes this guy positive. Negative and a negative makes this guy positive. Negative outside, negative 6 makes this guy positive. So the negative 3x to the third and 3x to the third add to 0. Negative 4x squared plus 9x squared makes 5x squared. 5x plus 6x makes 11x. And then we drop down the next term, which is a minus 1. And we start the process over. So we ask ourselves, what times x squared gives us 5x squared? Well, I know that to be a 5. So 5 times x squared makes 5x squared like what I planned. 5 times 3x makes a positive 15x. And 5 times 2 makes 10. And then again, subtract. So negative times a positive makes a negative. Negative times positive makes negative. Negative times positive makes negative. 5x squared minus itself is 0. 11x minus 15x makes a negative 4x. And negative 1 minus 10 makes negative 11. And there's no more numbers to drop down. So that means this is the remainder. We also know it's a remainder because there is nothing that I can multiply to x squared in order to get a 4x. since this exponent is higher than the one that I need, I can't make that happen. Nothing times x squared, a whole number, will give me an x. And so we have a remainder. So I'm going to label it. So this guy right here is our remainder. So the way we write our final answer is we take the whole portion of the answer, which is 2x squared minus 3x plus 5, and then we add on the remainder divided by what we divided by in the beginning, which was x squared plus 3x plus 2. So this is the quotient of the division of the two given polynomials. I want you to try example 5 on your own. Please remember if there are any missing terms, so look at your exponents, highest to lowest, and if you are missing one, make sure you replace it with a 0. 3, 2, 1, nothing, 1, nothing. Pause the video, try number 5 from start to finish by yourself. And here was your solution for example 5. So we ended up having a bunch of zeros in this very first step. And that's okay, run with it the way you would normally. So 0x squared means I need a 0x on the top to multiply correctly to get a 0x squared. Then at the end, we see that I don't really need this 0x in my answer. So I can simply take out the 0x and write my answer as x squared minus 2 plus 6 divided by x minus 1. Finally, let's look at an application problem. So example 6, the volume of the rectangular prism below is given by V equals 2x to the third plus 17x squared plus 46x plus 40. What is the length of the missing side in terms of x? Well, let's first start off by what do we know about this rectangle? Well, I know that this is the height, I know that this is the width, and I know that this missing side is the length. That's what I'm looking for. I don't know what that is. I also know that this is the volume. This giant polynomial is the volume. And so if I remember back to 8th grade, I know that volume is length times width times height. Well, I know part of this already. I know width and height, so I can at least figure out that. So let's do that first. So step 1, let's figure out what width times height is. Let's figure out what that is. So width times height will equal, the width is x plus 4, and the height is x plus 2. So I'm going to multiply these out. So x times x makes x squared, x times 2 makes 2x, 4 times x makes 4x, and 2 times 4 makes 8. So we can add these two middle terms together. So we get x squared plus 6x plus 8. So that's what width times height is equal to. Now, I'm looking for length because I know the volume. So let's think. If I want to solve for length, I'm going to have to divide out the width times the height on both sides. So what this turns into is that volume divided by width times height is equal to whatever the length is. Okay, well, let's think. Well, here's the volume. Then I found width times height in step 1. I have everything that I need in order to solve this problem. Well, let's go plug in what we know. So again, this turns into volume is 2x to the third plus 17x squared plus 46x plus 40 divided by, and then whatever width times height is, which I found earlier right here, x squared plus 6x plus 8. And the division of these polynomials will give me the length. So I'm going to assume that this numerator does not factor. And so we need to long divide these polynomials. So we end up with 2x to the third plus 17x squared plus 46x plus 40 on the inside of my division sign, x squared plus 6x plus 8. Okay, and we start our long division process. What times x squared will give us 2x to the third? I know that 2x will give me what I need. 2x times x squared gives me 2x to the third. And then continue to multiply. 2x times 6x makes 12x squared, and 2x times 8 makes 16x. And then we subtract. So this turns into a negative, this middle one turns into a negative, and so does the last one. And so we end up with 0 here. 17x squared minus 12x squared makes 5x squared. 46x minus 16x will leave us with 30x. And then drop down our 40. And then we start the process again. What times x squared gives us 5x squared? And so we end up with, I know that a 5 will do the trick. So 5 times x squared makes 5x squared. 5 times 6x makes 30x. And 5 times 8 makes 40. So then we subtract. So this becomes a negative, this becomes a negative, this becomes a negative. So 5x squared minus itself is 0, 30x minus itself is 0, and 40 minus itself is also 0. So we have a remainder of 0. So what that means is, first of all, that means that this actually did factor out nice and pretty. Second of all, that means my length is simply 2x plus 5. So the length is 2x plus 5. That would be the missing length of this rectangular prism.